Hello, today I'm going to talk about another worked out example of BJT. So before doing that, let's look at some of the current voltage relationships in the active mode of BJT. So you can see here IC, let me go back. So you can see here the equation for IC in these are the equations in active mode. Then IB, so IC is equals to ISC to the power VBE by VT. IB is equals to IC by beta. IE is equals to IC by alpha. So these are the equations for NPN transistor. Remember this, these are equation for NPN and for the active mode operation. Okay, now, and one thing for we need to know that alpha is equals to beta by 1 plus beta, and Vt is equals to thermal voltage, that is Kt by Q. At room temperature it is 25 millivolt, around 25 millivolt. For PNP transistor, what we need to do is substitute this VBE with VEB. These are the changes. Okay, so remember, these active mode equations you can only use when you assume the circuit is to be operating in the active mode, or you actually are sure that the circuit is actually working in the active mode. And one saturation region equation is not only saturation but also active mode equation is IE is equals to IC plus IB. So this is a universal equation for BJT. Okay, so for NPN, for today's math I'm going to need this. It is just a reminder. So if you need your BJT to be flowing the current or turning on, so you need a zero point 0.7 voltage difference between base and emitter. So you need VBE at least zero point 0.7. Okay, you need VBE at least 0.7 volt, and to be operating in the active mode or saturation mode. For example, if it is in the saturation mode, see that the difference between collector and emitter must be in between 0.3 volt. So VCE must be less than or equal to 0.3 volt for saturation. Beyond zero point 0.3 volt it is active mode operation. Okay, now let's move on to today's example that I'm going to talk about, that is example number 4. So this particular example is from the book Microelectronic Circuits by Cedric Smith. It is located at most probably the page number 336 or 337. You can go and take a look. The precise example number is 6.5 of the book. So let's talk about in solving procedure of this particular problem. So see that first of all, let's decide. Let's see whether this is a NPN or PNP type BJT. So we can easily find out by the direction of the arrow that it's an NPN BJT. So first thing is noted here that it's a NPN BJT. Okay, fine, one thing is done. Now you can see that there is a voltage source connected at the base, so it is VB is equals to, so we know the value of VB, that is equals to 6 volts, right? So if it is needed to be turned on, we know that VBE must be 0.7. In that regard, VBE must be zero point 0.7, right? 0.7 volts VBE. So that points out that your VE, should be at, let's read right here. So VE should be at 0.7 volt less, that is 5.3 volts. Okay, so see that I have found the value of VE. I have found the value of VB, that is 6 volt. VE is 5.3 volt. and easily I can find the value of this current, that is emitter current, IE, right? So IE is very easy to find. So IE can be found. So let's try to find out IE. So IE is equals to, we can easily see that VE divided by 3.3k, right? So it is around looks like it is around 5.3 divided by so what's the value here is 1.6 milliampere, most probably, if I'm doing the calculations correctly. 1.6 milliamperes IE. Okay, fine. So up to this point, see that I haven't actually assumed that whether the BJT is in the saturation or active. So till now we can easily write equation without assuming its working mode, right? So now I have to assume to proceed further. So let's say I am assuming the BJT to be working in the active mode. So now I can use the active mode equations. So I have assumed the BJT is working in the active mode. So with this IE, now I can find the value of literally anything, that is like IC. So if you recall properly, IC is equals to nothing but alpha into IE. As I know the value, of IE, that will provide me with the value of IC, because beta is given to be 50, right? So alpha should be beta divided by 1 plus beta. You can easily find out. So if I calculate the value of IC now, I found the value of IC, right? Easily I can find the value of IC. Then with the help of IC, if I calculate the voltage of collector, that is VC, I find that it would be a drop at across this resistance. So 10 minus 4.7k, 4.7k into IC. So 10 minus 4.7 into IC, right? Sorry, into IC. Okay. So now if I do this calculation, I will get the value of VC. Now value of VC, I have calculated this thing for you. Value of VC is found to be 2.48. So it's 2.48. VC is 2.48 volt. Now let's check whether I am actually heading towards the right direction or not. Now in order to see that, I have assumed that it's working in the active mode. Now in order to be this in the active mode, the difference between collector and emitter should be greater than zero point 0.3 volt, whereas you can easily see that my collector voltage is 2.48 but my emitter voltage is large. So VC is a negative value and it's obviously less than zero point 0.3, right? So now it needs to be greater than 0.3, but it is less than 0.3, definitely less than 0.3. So our assumption is totally wrong. So it isn't in the active mode, it is not working in the active mode, so definitely it should be working on the saturation mode. So then our whole assumption is wrong. So now I need to solve the whole math again. I need to solve the full math in assuming that it is in the saturation region of operation. So in order to do that, let's clear up the screen first. Okay, so I have cleared the screen to a certain extent. Now let's move on to the problem again. So now let's try out the saturation region approach, right? So for saturation region approach, if you recall, previously I have talked about, if it is in the saturation region, then VCE will be around zero point 0.3 volt. So let's assume that VCE is zero point 0.3 volt because it is working in the saturation region. Now I'm pretty much sure, right, that it is working in the saturation region. So VCE is zero point 0.3. So I know the value of VE. Remember, VE was most probably 5.3 volt, right? This was 5.3 volt. So VC should be then 5.3 plus, you can take VCE, you can take point 0.3 or point 0.2. Okay, it's your wish, because in saturation region, point 0.3 means edge of the saturation and point 0.2 means deep in saturation. Okay, so it is better to take point 0.2. It's an empirical value. So this gives, if you take VCE, the voltage difference between collector and emitter is zero point 0.2, then your VC gets 5.5 volt. Okay, so now I can find the value of VC. From this VC I can easily calculate IC in similar approach. That is, IC is equals to 10 minus this 10 minus this node divided by this resistance, right? 10 minus 5 VC divided by 4.7. Okay, the value I found here is, let me calculate it for you guys. So the value I'm finding is 0.96 milli. 0.96 milli. Now I can find the value. Right now I know IC, so now I can find the value of IB, as I know the value of IE. Previously I have calculated the value of IE. Now I can find IB. So IB is, I can use the universal equation. Let me do it here. This will be much more easy for me. IB is equals to IE minus IC. If I do this, remember, most probably IE was around IE was 1.6. You can see here IE was 1.6. So if you subtract 1.6 to 1.96, it becomes 0.64 milliamps. 0.64 milli. So now, so my my goal was to find all node voltages and currents. Now see that I have found the voltage of base, emitter, collector. So all node voltage have been found. Then collector current, base current, and emitter current, everything was found, right? So my goal is now fulfilled. So you can actually find the value of beta. Let me tell you one thing, that when the BJT is working in the saturation mode, the beta value of the BJT is changed if you check it properly. Now if you calculate the new beta, that is the ratio of IC to IB, you'll get new beta, that is the ratio of IC by IB, you'll get it to be around 1.5. So it is pretty less what you find in a normal BJT. If you test BJT, an NPN BJT, using a multimeter to find the beta, you'll see it, the beta is around 150 to 250. Okay, but if you place that BJT in a circuit that is working in saturation region, you will see that the beta is reduced to a very low level. So it's something like this. It gets below 80 or 50. Okay, so the thing you see here is beta is actually reduced in saturation region. Thank you guys. If you have any question, please do comment.